So the first thing I want to talk about is the torque on the lead screw and what goes into that. Of course, the lead screw has its own torque between the lead screw and the super nut, but all of the alignments of the housing of this support plate right here and of the super nut down inside here, how it's torqued and assembled, goes into the alignment and how it affects the resultant torque on the lead screw. So what I like to do is I like to position the whole assembly down close to the support bearing here, and then I start tightening the screws up, these two here, these four small ones here, and the super nut screws, the three inside there, so that it's in the best alignment possible. And then I measure the running torque at three locations, once here, once in the center, and once down here. And I will demonstrate that. We have a little pulley fixture that has a radius of 2.54 centimeters or 1 inch. And so what I want to do is I want to measure using a gram scale, and I want the load to be between 50 and 125 grams, and this right here is running about 75 grams. So then I can run it down to the center here, and we'll retest it. And it's running about the same, 75 grams. And then I'll run it down to here. And we'll retest it one more time. Same number, about 75 grams. So this would be a pass. It's between 50 and 125 grams. And so this would be ready to go, assuming that everything is torqued up. So now I want to talk about adjusting the preload of the super nut that's on the lead screw. And the super nut has three parts to it. It has the front nut, the rear nut, and a cam spacer that's in between the two. And there's a torsional spring inside of here that actually pushes these two nuts apart based on this incline ramp right here on the cam. So the way to do it is, first of all, you do it by feel. You hold the front nut, and you can kind of rotate the cam right here and feel what kind of tension's on it. And if it's really loose, then you can increase the overall preload by making more tension in the torsional spring. So to give you an example, and the way to do that is you have to remove the rear nut from the assembly, and then rotate it one position, that was one position counterclockwise, and it actually opened this spacing here, so I actually dropped the spring constant. So I needed to go the other way. So now I'm going to rotate it one clockwise, one more clockwise, spacing is about the same. I'm going to take it one more, and I'm holding the whole thing together. So as I close this gap here, it's increasing the preload just a little bit. There's one location on the nut, a little bit tighter, And if I wanted to go one more, see if that, there. Now I've closed the gap even more, and I've increased the preload by that amount. So the only way to really test it is to put it back in the total assembly here and go through the test procedure that we just went through earlier and see what kind of torque. And that should eliminate all looseness within the assembly. You should be able to feel a pretty decent preload right here, and you can also feel it by just turning it by hand and feel that it's smooth and not super high resistance but not loose. It's kind of a feel thing.